So we've been looking at conditional probability, and we've said this. First of all, there is a trigger word. The trigger word is given that, or suppose, or if. And I've said to you, we're going to try and set up a tree, and we're going to this time use a formula. And the formula is and both divided by the given one. We're going backwards up the tree. Example 3. Cards. Find example 3. A card is drawn from a shuffled deck of 52 cards and not replaced. Then a second card is drawn. A says, what's the probability that the second card drawn is a king? B says, hey, what's the first word of part B? Conditional. We'll come back to that. A. How many cards are we picking? Read the question. How many cards are we picking? Read the question. 2, tree. What if we're picking 5 cards? We're going to cheat, do that differently later on. I'm going to show you for 5 cards, we're going to use combinatorics from last unit. We're going to turn these trees into chooses. But how many cards are we picking here? 2, tree. Okay, so the tree is going to look like this. Well, Sean, what are they asking me to find? Can you read A to me, please?
What is the probability that the second card drawn is a king?
It depends. What does it depend on? Whether the first one is a king. So you know what? Our tree is going to have 2 levels, and it's going to be king on the first, king on the second. Our tree is going to look like this. King 1, not king 1. Right? King 2, not king 2. King 2, not king 2. We've set up our tree's scaffold. Now let's actually weight the branches. Let's put weights on them. What fraction is going to go on the branch for king 1? How many kings are there in a deck?
4.
Out of? How many non-kings are there in the deck? 48 out of 52. Hopefully you were clever and used the complement and didn't count. Let's move down the king 1 branch. Okay, down this branch, we picked a king. How many kings are left in the deck now? 3 out of? How many non-kings are in the deck? 48 out of 51. Down this branch, we didn't get a king. How many kings are left in the deck? 4 out of 51. And? Okay. 47 out of 51. Sebastian, what are they asking me to find here? Yeah.
What the probability is that you draw in.
Just read to me the question.
What is the probability that the second card drawn is?
And this is key. The second card, you said a king. No, they want the second card to be a king. So what branches end with the second card being a king? That branch or that branch, right? What does or mean? Add. Okay, so it's going to look like this. If I wanted to write this in probability notation, we're really saying we want to find the probability both are kings or not a king followed by a king. I don't find the notation very helpful. I write it out just for practice. I find the tree much more helpful because, Ellen, to me, the tree is pretty obvious. If you had written that for me and had me try to visualize, but I think that's what we're saying, right? It's going to be king 1, king 2, or not king 1, king 2. So there it is in notation. Let's just put in the fractions. It's going to be 4 out of 52 times 3 out of 51, or 48 out of 52 times 4 out of 51. How do I multiply fractions? That's the easiest. It's top times top, bottom times bottom. I think this is 12 out of 2652. 48 times 4. 192, I think. Double check me. Out of 2652. If we don't go to lowest terms, it looks like the answer is 12 plus 192, 204. Now that's doing it by hand. Rachel, of course, you could have just wimped out and gone to your fraction button and you could have said, oh, it's 4 out of 52 times 3 out of 51, or 48 out of 52 times 4 out of 51. Did I type that in right? 4 out of 52, 3 out of 51, or 48 out of 52, 4 out of 51. And then in lowest terms, it tells you, oh, the answer is 1 out of 13. Okay. I don't care which approach you use. Yep. Can you borrow one off someone? Someone have one they can loan, Sebastian? Or else come here and grab a golf pencil. There's one down here. Okay. Connor, can you read B to me, please? What? Sorry, what did you say? First word? Given. This is conditional probability, and I've said here we want to translate into a formula. This is what you need to pick up from today's lesson. So, ready? What do they want me to find? The probability of bracket. What's the given? So it looks like this. Given king 2. What do they want me to find? What symbol is that on my tree? What symbol? Huh? Not king 1. That's what they want me to find. And again, we're going backwards up the tree. What I'm telling you, Sean, is, okay, suppose I tell you that you're in one, go backwards up. Tell me what the odds, what the probability is that you came down a certain branch. And here's what I've said. It's both over the given. I don't try and figure out what symbol goes with where. I know, you know what? It's not king 1 and king 2 divided by king 2. Both over the given one. Both over the given one. Both over the given one. Can you tell me what I would write for the top? Not king 1 and king 2? And? What does and mean? Okay. So the top is going to be definitely a 48 out of 52. And? Keep going. Yes. See how the tree is reading the tree. Got to be careful, but reading the tree. What's going to go on the bottom? Well, conveniently, we just figured out, I think, king 2. Did we not? But really what we would say is this. Any branch that ends in a king 2 is going to go on the bottom, which is 4 out of 52, 3 out of 51, or, because or means add, 48 out of 52, 4 out of 51. Christina, let me rehash that, okay? So you translate it into a given statement, and it's going to be both and, which is that and that on the top, divided by the given one. What's the given one? Any branch that ends in a what? K2. That or, did I say or? What does or mean? Add, that's where the plus came from. And to get the branch, you multiply down. You will notice very often, in fact, almost always, that this number shows up somewhere in the denominator as one of your pluses. You can't cancel them. Don't think you can cancel them. You can't. But you'll know you're doing it right if that occurs. Is there more than one fraction on the bottom? Yeah. Is there more than one fraction on the top? Yeah. Get your calculators out, all of you. I think we need brackets. To type this, I think we'll put the top in brackets and we'll put the bottom in brackets. I think we'll go like this. Bracket 48 out of 52 and 4 out of 51. Close off the top. Now what? Divided by bracket 4 out of 52 and 3 out of 51, or 48 out of 52 and 4 out of 51. Close off the bottom. Practice typing that in. This is the reason I said everybody get out your calculators. What's the answer? Apparently, and to me, that's such a counterintuitive answer. When I look at that tree, when I look at the fractions in that tree, if you asked me to guess what my answer would be out of, 17 would have been the last number I would have picked. I see 52s and 51. I might have thought something like 17, really? And apparently there's a 16 out of 17 chance that if you got a king on the second draw, you didn't get a king on the first draw. There's a 16 out of 17 chance that you don't have two of a kind. There's a 1 in 17 chance that you do have a pair, which is why a pair would be a good hand. Everybody get that okay on their calculator? Brooke, you got that okay on your calculator?
Got it.
Just got it? Yep. Roy, is that a hand up?
Yeah.
Yeah.
Can you just use the one where...
Yes. Roy says, hey, Mr. Dueck, because in part A I had figured out the two king twos, could I have just gone like this? 48 out of 52 and 4 out of 51 divided by, what was it, 1 out of 13? And the reason I did this the long way is sometimes I won't have asked you part A already, and I wanted to let you know if I don't grade. But yeah, totally. Because we'd figured out the bottom already. C. Hey, Roy, you're on such a roll. Can you read C to me, please? I'm going to try it again without people talking. Read C to me, please. Oh, hang on, I forgot to write the answer. What was the answer? 16 out of 17. Okay. Now let's go to C.
What is the probability that the second card is wrong as the first card?
Depends. You know what it depends on? If the first card is a face card. What's a face card? Okay. I think we're going to have how many cards are we picking? 2. I think we're going to have a 2-level tree, and it's going to be face card on the first, face card on the second. It's going to look something like this. I'm going to do the tree over here because I need more room. So F1, not F1, F2, not F2, F2, not F2. What's a face card? Okay, so there's 3 of those. Did you say Jack, Queen, King? Hang on, don't write yet. 3 of those in each suit. How many suits are there? How many suits are there? 4. So if there's 3 in each suit and there's 4 suits, use the fundamental counting principle to figure out how many face cards there are. 12. Okay? You're going to need to get familiar with a deck of cards, folks. So, how many face cards are there in the deck? What did we just say? 12 out of? Okay. So 12 out of 52. How many non-face cards? Use the complement. 40 out of 52. Down this first branch, you picked a face card. How many are left in the deck? Out of? How many non-face cards? Down the right-hand branch, you didn't get a face card. How many face cards are left in the deck? Out of 51 and 39 out of 51. By the way, going back to Jordan's question, we were talking about the test for independence. This is the easiest one. See that F2 and see that F2? Are the branches the same?
No.
Then they're not independent, they're dependent. That's the easiest test. I can glance at a tree, and if the branches aren't identical, I guess the odds, what happens at the beginning affects the odds of what happens on the second level. Is that okay?
Yep.
Okay. So we want the probability of the second card being a face card. Hey, what's that going to be? Talk me through it. What will I write? $12 out of 52 times 11 out of 51. That branch. Or that branch. Right? Which is what? You need to know how to calculate these. So if you don't know how to do this, get your calculator out and practice, please. I think if you do this the long way, it ends up being over 26, 52, and I think it ends up being 132 plus 480, 586. I think it ends up being 612 over 2652, but most of you are using your calculators. What is it in lowest terms? Sorry? 3 out of 13. Okay. I mean, the 13 to me doesn't surprise me as much because there's 13 cards in each suit. When a 13 shows up, I'm kind of, oh, okay. It's that 17 on the previous question that really I went, wow, where'd that come from? I don't know of any groups of 17 in a deck of cards. Okay? Cole, can you read D to me, please?
What is the probability that the first card is a face card given
Sorry, what word did you say after the comma?
given
Conditional. Keep going.
that the second card is not a face card?
And can you see, here's what they're saying. Find the probability of what?
The first card is a face
First level, given an event that happened on the second level. We're going backwards up the tree. Going backwards up the tree. Let's translate this into a formula. Cole, what's the given? What did they tell me that we know?
second card wasn't a face card.
Not F2. What do they want me to find? Is that okay? Yeah? Good. Try this on your own. I'll do it up here. Look up if you get stuck, but don't just mindlessly copy. This is going to be It's both and over the given. See a whole bunch of people copying, so I'm freezing the screen. Or uh-oh, I'm making you figure it out now. So look at the tree, look at the symbols, see if you can figure it out. Probably something like that. Twelve 40 divided by 12, 40, or 40. I'm missing a number. Boy, that was dangerous. Thought something was bugging me. Is that right, Mr. Dueck? Now let's go check your tree. You said it's going to be... Oh, you got to scroll up. You said it's going to be both, which means that and that, over the given one, which means that branch or that branch. Get that? Get that? Yep. I'm getting 4 out of 17. How many of you got that okay? Okay. How many of you would like me to explain where the numbers come from? I don't mind doing that if you need me to. Okay. So can I pick on you? Not to make fun of you. Ready? Read this to me out loud, starting with black here. Probability of what? Just read the symbol. F1. What's that vertical line mean? It's a word. No. Okay, you need to memorize this, and you better do your homework. What's the vertical line mean? Given. Okay, so you ready? Start over. Probability of given. Yes. Which is always going to be both of those and divided by the second one, the given one. With me? So that's why I said it's going to be that and. What does and mean? Yes. Divided by that. You with me so far? So then I went to the tree. Which branch has both of those? Boom, boom. See it? Yep. Divided by 2 branches end in that. That one or that one. Hey, what does or mean? That's where the plus sign came from. That branch is this one. Or that branch is this one. And then carefully, carefully, carefully type it to your calculator. Is that all right? We're going to do a bunch of these. We're going to do a bunch of these. In fact, I may just save your life. Let's find out. Example 4. It's disturbing to me how many doctors do not know this mathematics here. And I'm going to go serious on you in a few minutes. So, shush. It says this. Suppose you know that 3% of the population suffers from a certain disease, some type of cancer, let's say. And there is a test, and the test is 95% accurate. Suppose you take that test and you test positive. What's the probability that you actually have the disease? Far too many people would say, well, if the test is 95% accurate, that means there's a 95% chance that I have cancer. Far too many doctors will say, well, this is a 95% accurate test. You tested positive. Sean, that's a 95% chance that you have cancer. That is not the case. But the terrible, the horrible, the tragic thing is, people think, oh, it's a 95% accurate test. I have cancer, and people will choose to take their own lives before the cancer runs its course. Actually, these numbers here suggest there's a good chance you don't have cancer. Really? I tested positive, and there's a good chance that I don't have cancer? Yes. Let's prove it. Okay? Let's use, how about D for disease? What would be a good letter to use for testing positive? P for positive? Okay. What's the first word of the third sentence? Given. It's conditional. What's the given? What do we know? Given what? Read the sentence. Find this word. See the word given? See it? Given what? Don't worry, we're not doing percentages yet. Given what? Test positive. Find what? This is what we're finding. And that also helps me figure out what my tree is going to look like. Because we said in conditional, you're going backwards up the tree. This is going to be the bottom. This is going to be the first level. My tree is going to look like this. Disease or not. Positive, not. Positive, not. With me so far? Okay. What percent of the population has the disease? So this branch here is going to be 0.03. By reasoning, what percent of the population doesn't have the disease? 0.97. Now, let's walk down this branch here. In this branch, the person actually has the disease. Okay? Should they test positive or negative if they have the disease? Positive. How often? How accurate is the test? So 95% of the time you'll test positive. 5% of the time the test will miss it. Down this branch, do they have the disease or don't they? They don't. So what should they test, positive or negative? So 95% of the time you should test negative. 5% of the time you'll get what we call a false positive. Okay, see how we set up our tree? And see how I targeted that key trigger word, given, and I said, given what? That gave me the second half of my statement. Find what? That gave me the first half of my statement. Oh, and I've told you that this is going to be both over given. Ready, Jake? I'm going to pick on you. Which branch is both? What are the numbers? Read them to me.
0.03 and 0.95.
Did you say and? Why, I think that means multiply. Right? I heard you.
Yeah.
Over, what letter is the given one? In my initial statement, which of these two letters is the given one, the D or the P? The P. This is key, because every year I have kids think the D. No, it's D, given P. Okay, the branches that end in P. Two of them, yes?
Yeah.
So it's going to be 0.03, 0.95, or 0.97, 0.05. Is there more than one number on the top? Brackets. Is there more than one number on the bottom? Brackets. Try typing this in. You will not find that you have a 95% chance of having cancer, even though this test is 95% accurate and you've tested positive. You'll find it's far lower. Far lower. Did I type that in right? Oh, I'm missing a decimal. Let's try that again. 0.03 times 0.95 divided by 0.03 times 0.95 or 0.97 times... Do you get 0.37? Or, what's the probability that you have cancer even though you've tested positive? Actually, you probably don't have cancer. It's only a 37% chance that you have it. And this is such a counterintuitive answer. And, yep.
How are they supposed to know who does it?
You always, Rachel asked a great question. You always go for a second test. Always demand it. If you're ever in a situation, ask your doctor. Do the test again. Now, if you extend this tree 2 or even 3 more levels, and you test positive 3 consecutive times, okay, then you start to find, if you test positive 3 consecutive times, then the probability ends up being in the 80s or 90s, and you probably have it. Oh, instead of disease, let's think testing positive for a banned substance if you're an athlete. Always wait until you hear the results of the second test before you judge. Oh, any of you wanting to go into law? Suppose you know 3% of people will lie in court, 97% of the people will tell the truth, and you have a polygraph test that's 95% accurate. If a person flunks a polygraph test, what's the probability they were actually lying? They were probably telling the truth, even though they flunked the test. This is why you can't use a polygraph test in a court of law. Cannot. Oh, speaking of polygraphs, Tiffany. Tiffany has been accused of a crime, sorry. And she volunteers to take a polygraph test to clear her name. From previous studies, we know that people tell the truth to the police 98% of the time. And the polygraph test has an accuracy of 96%. Uh-oh. Tiffany flunks the polygraph. Is she guilty? What's the given? What would be a good letter to use for fail? Okay, so let's go like this. What's the given? Fail. What do they want me to find? Put your phone away. What do they want me to find? Probability of what? That she's lying. What would be a good letter to use for lying? L? Okay. By the way, that helps me figure out how to set up the tree, because in conditional probability, we're going backwards up the tree. The second number is going to be the second level. The first letter is going to be the first level. So it's going to be like this. Lying, lying, telling the truth, fails, Doesn't fail or passes. Fails. Doesn't fail or passes. You liar. All right, let's fill in the weighted branches. What percent of people from previous studies do we know lie? Ah, good, not 98%, because I told you 98% tell the truth. So what percent lie? 0.02, 0.98. Now, how accurate is this polygraph test? Okay, now down this branch, she's a liar. Should she fail or pass the test? She should fail. What percent of the time? How accurate is this test? Down this branch, she's telling the truth. So, should she pass or should she fail the test if she's telling the truth? Should she pass? How often? How accurate is this test? So, she should pass 96. She should only fail it 4% of the time. A false negative in this case. A false fail. Good. Crunch the numbers. Remember, it's both and divided by the given one. Is she a lying weasel criminal? I see about 5 of you nodding your heads. Jake, are you getting the hang of where the numbers come from now? And they can be fractions or decimals, right? I also need you to practice typing this into your calculator because it does me no good if you can write it, but you can't get the correct answer. So if you haven't tried typing these in, make sure you know how to use the brackets and everything. You get what I got? Yeah? So, Sean, here's the weird part then. Failing the test actually suggests she's telling the truth. Sorry. It's a counterintuitive answer, Erica, but this is conditional probability. This is one of the reasons I love this unit. It's for this particular lesson. So, 0.329. You may have wondered, hey, why don't they use polygraph tests in a court of law? This is why. They're meaningless. Unless you can get a polygraph test that's 100% accurate, and we can't. We have no such thing. As soon as it's possible for the polygraph test to make a mistake, what you're going to end up with are a whole bunch of false fails, false negatives. Because you know why? Most people will tell the truth. And because so many people are telling the truth, you're going to have a large number of people telling the truth that fail the test anyhow because it's a not perfect test. Let me depress you. Sorry, but let me depress you. Suppose you know that only 2% of the population is racist. 98% of the population is not. And suppose only 4% of the population is a minority. Given that you're a minority, what's the probability that you'll encounter some racism? Even if only 2% of the population is racist. Sorry. I mean, it's a fascinating theorem to me because it has some interesting social implications. Turn the page. Is this the last one? Okay. Jar A contains 4 black, 2 white marbles. Jar B contains 4 black, 8 white marbles. We pick a jar, we pick a marble. You know what? I think there's 2 events. Jar, first level. Marble, second level. That's a job for a tree. So let's draw our tree first. Jar A, jar B. What are the odds that we pick jar A? I think it's a half and a half because they didn't give me any kind of a procedure to go through. I said to you, sometimes I'll let you pick a card or I'll change the odds somehow. It looks like in jar A we have black and white, and in jar B we have black and white. What's the probability that we're black if we're in jar A? 4 out of 6, 2 out of 6, and 4 out of 12, 8 out of 12. Got our tree? We're not going to do part A. We're just going to talk about it. Christina, can you read to me part A? What does it say?
What is the probability that?
You know what? That branch or that branch. Multiply down that across. It would be 1/2 times 4/6 plus 1/2 times 4/12, whatever the heck that is. Okay? I'm not going to do that, but that's what it would be. I'm more interested in part B. Colin, can you read to me part B? Sorry, what did you say? That's my trigger for a conditional probability question. This is the one time I still set it up as a tree, but I use the formula to figure out where the numbers go. So let's pick up our pens. Let's do part B. Colin, what's the given? W. What do they want me to find? Going backwards up the tree. Good, try this on your own. By the way, this B is a jar, this B is black. Sorry, I shouldn't have used the same letter twice. That was sloppy. I should have gone A, not A. Black, white, or something like that. Anyways, don't get the B's confused. Jar B, then white. I think you get a nice fraction answer. Like a small fraction, yeah? Get an answer? No? Yeah, right? 2 over. So double check your bracket, double check your brackets, double check your numbers. Yeah. Roy, coming back to you. Earlier you had said, hey, can I use that 1 over 13? Yes. But here's what I like about writing it out. This is one of my built-in error checks. 99% of the time, what's on top shows up somewhere in the bottom. If it does, then probably I'm doing it right. What's on top shows up somewhere in the bottom. If it does, then I'm probably doing it right for conditional. What's on top shows up somewhere in the bottom. I'm probably doing it right. It's a small error check, but I like those things. It's like, I don't think I'm messing up. You get 2/3? What's your homework? Got to practice this. So what's your homework? Take a look at this. This is called Lesson 5 homework. Okay. Give you some hints here, throwing lots of this at you. In number one is no conditional yet because I don't see the word. It just says find the probability that the chosen marble is blue, green, red. Use a tree and figure out the branches. No conditional yet. Number 2, it says what's the probability that both marbles are the same color? I don't see a given or a suppose or an if. No conditional yet. Conditional for number 3 because it says if it's known. That might be a conditional, maybe not. Actually, you know what? I take that back. Number 3 is still not conditional because negative is at the bottom branch. You're just going to go down the branch. Take that back. Number 4 is your first conditional right there. Okay. 5, I see the word given. That's a conditional. Probability that Roy will be late. Typo, sorry. Part B says give that Roy. It should be given, that word right there. My bad, I'll fix that. Given that. For some reason, there's a blank page. I fixed that, but it's there. So 7 is a conditional towards the second part. I see a given that. Balloons. And then making some machines. See if you can figure these out. Monday, you can expect a take-home quiz, and we're going to press pause. Monday, if you haven't finished Lesson 4, if you have questions from Homework 4, I'll still take it. I'll take questions from Homework 5. I'll give you time to work on Lesson 5. You'll have a take-home quiz that's going to be fairly big. You'll work on it in class, and we're pressing pause.